Alrighty, hi there, Addie. Today's lesson is lesson number 5 in our algebra. We are cruising through all of this, and this is going to be super fun. You know that I am doing this very late at night, so if it doesn't completely make sense, it's because it's either late at night or because I might have already taken a little something to help me sleep. But either way, we're going to get through this because you only need half a brain to do this. It's going to be that easy. It is so good. First of all, don't be mad at lazy people. They didn't do anything. No, they didn't. They were too lazy to do something. That's hilarious. Okay, today's lesson, we are going to go over sets, and we're going to learn about sets. We're going to learn about absolute value. Don't worry, I think you already know about absolute value, but we're going to definitely take it to the next level, so you still have to pay attention. And also addition of signed numbers. So those are negative numbers, positive numbers. You're going to learn how to make sure and add those together correctly. First of all, what is a set? Well, here's a set of dishes, and if you define a set, it says a well-defined collection of numbers, objects, or things. So you can see how this would be a set of dishes. And guess what? Just like some people collect sets of dishes, some people collect sets of numbers. Isn't that cool? Okay, so some people might have a collection that looks like this. And this first part tells you the name of the set. So they have designated set A as the name of it, and set A is the set whose members are the counting numbers 1 through 5, inclusive. Okay, so when you have brackets like this means that you're talking about a set. When you say the word inclusive, that means when you say 1 through 5, that means including 1 and including 5. So that's what they mean by inclusive. Okay, so this set is the counting numbers 1 through 5 inclusive. You could also write it out in words. Set A is brackets, that means it's a set. The set of counting numbers 1 through 5 inclusive. Okay, so that makes sense. You've got a set of numbers right there that somebody might collect. You know what I'm talking about, right? That's like that lady's face when she does not know what the guy's talking about when he's talking about cappuccino or something. I don't know. Anyway, I hope you know what I'm talking about here. But we will move on to a different set. So some people, once they have collected that set, they want to collect the next set. Here's another set that some people might collect. It's a set of natural numbers. So natural numbers, you remember, are the same, are natural numbers and counting numbers are names for the same set, because natural numbers are the same as counting because you start with 1 and keep going up from there. But this set is a little bit different because I'm going to point out this, which this hand is pointing to here. And this ... of course, means that this goes on forever without end. It's an infinite set. Oh, that's cool. So you start with 1, you go through 5, and then it includes, because of the ... that includes all of them, continuing on from there. That's what the 3 dots indicate. It goes without end. All right, now that is one set that somebody might collect. That's their collection. Look at this lady with this weird collection. I mean, I don't know. Is it weird to collect numbers? It's weird to collect these ugly dolls. Those are creepy. Ooh, I don't think I would even want to be in this room. That's really crazy. You know what? I don't mean to be rude, but she kind of looks like a troll doll. Does she? Look at her face. Look at her eyes. I don't know. That's creepy. All right, let's move on. That's too creepy for me. What about whole numbers? So if you add a 0 to this set, I mean, people are particular about their sets, right? Like you couldn't just give this lady any doll that's not a troll doll and be like, here, put this in your set. She'd be like, no, that's not part of my set. And so a whole number is a whole different set than natural numbers. Whole numbers includes the number 0. And remember how I said you can remember that? Like whole, if you just look at this part, a whole looks like the number 0. So it includes the number 0 and then also includes the counting numbers above that. Okay, what if you started including negative numbers in this collection of numbers? If you start including negative numbers, now it's not called whole numbers anymore. It's going to be called, it's a new set. It's going to be called integers. So integers are the set of natural numbers and 0 and all their opposites. And guess what? There's a dot, dot, dot here and a dot, dot, dot here. So integers includes this set, but it goes without end in both directions. All right, sweet, mathematical. Let's go over absolute value. Absolute value is cool. It's a really cool, interesting concept. Here we have a -7 and here we have a +7. But we're talking about value or absolute value. So the way that I think about that is, let's say that you have 7 sheep. You're in the olden days, you collect sheep, you have 7 of them. That number has a value to you. You know what 7 sheep means because you have them. You can see them, right? But what if you owe somebody 7 sheep? Like maybe you don't have 7 sheep, but you made some sort of deal with your neighbor and you're like, I owe you 7 sheep. Do you still have sort of that? If you look at the absolute value of sheep, the absolute value of sheep is the same whether you owe them or whether you have them. It's still 7 sheep that you can picture. So if you think about the absolute value, that's what that means. It describes that quality of how big or how what's the magnitude of it without thinking about the sign. It's sort of this quality of bigness of a number. Okay, so the way that we do that is we just write the numerical part without the sign. And of course, without the sign, if you just take away the sign, that means by convention that those numbers are now positive. So the absolute value of any negative number is going to be just that positive number because that represents sort of the bigness of it. Okay, so here's the rule. The absolute value of any non-zero real number is going to be positive. Now, what about 0 though? If you're talking about the number 0, 0 is just the magnitude of 0. So the absolute value of it still is 0. So the absolute value of 0 is 0. What about the absolute value of a +7? Well, the bigness of it, what's the bigness? It's 7. And they kind of wrote this in the book, but it just means 7. The absolute value of -7 is going to be a +7. And then they make the point that basically, but just sort of by convention, when you have a +7 in front of the number, you can say it without the plus sign. And so the absolute value of +7 is just 7, which is positive by convention. And the absolute value of -7 is 7, which is +7 by convention. Okay, so here's the rule. 2 rules. I thought of Dwight here because he's like, learn your rules. You must learn your rules. Anyway, so here's the 2 rules that you must learn about absolute value. The first one is, rule number 1, the absolute value of 0 is 0. Rule number 2, the absolute value of any non-zero real number is, that's not right. That's not the rule. That's not the rule. This is where the late at night. Okay. The absolute value of any non-zero real number is a positive number. That's the rule. Man, I made a mistake there when I was drawing this. Okay, so here's the 2 rules. The absolute value of 0 is 0. The absolute value of any non-zero real number is positive. So then they go over some examples, and these are really pretty obvious to me, so I don't want to spend a lot of time. But the absolute value of 0 is just 0. -5, and I'm going to go up and down, is just a 5, which is +5. And then even if you have a decimal, just write it without the sign. If you have a number, just write it positive. Here's another decimal that they wrote without the sign. And here's a positive fraction, and you just write the fraction without the sign. Those are the answers. Okay, let's do example 5.1, and I feel like they might get a little tricky here, so try and pay attention. First for A, they want to know the absolute value of -5. So the absolute value of any non-zero number is the positive number. So it's just 5. That's all you have to write. Okay, B. Here, we're getting kind of tricky because inside the absolute value brackets, you have a math problem. So they put 11 minus 2 inside. So the first thing we have to do is solve that problem, and it's going to be the absolute value of 9. 11 minus 2 is 9, and then you just get 9. So solve the problem first and then change the sign, okay? And C is showing you, oh, this is getting even more tricky because you've got a negative here, then you've got brackets. They want the absolute value of this part. But then what does this negative mean out here? Well, this negative means something different. They think about it and I think about it as the opposite of. When you see a negative out there in front of something like that, it means the opposite of the absolute value. So let's just take this one step at a time and start inside the brackets. 20 minus 2, we're going to simplify that to 18. Okay, now the absolute value of 18 is just 18. So it's just a positive 18. But then this negative out here is outside the brackets, so we can't change that. We can only change the sign when it's inside the brackets. If that were a negative, we'd make it a positive. But it's a positive, so we're going to keep it positive. But then that negative outside the brackets makes the answer this. Okay, so what we're saying is the absolute value of 18 is 18. But since we want the opposite of that, then the answer is going to be negative 18. Text me and tell me if that makes sense about the negative 18, okay? I can't wait to find out. I'm sitting on the edge of my seat eating some toast right now, waiting for you to text me. Okay, and I know you're waiting for this next section of the lesson. This is addition of signed numbers. And what they want us to do is okay, so we just introduced a sign, a minus sign that meant the opposite of. Minus sign always means to subtract, but in algebra, we also use the minus sign to show a negative number. So this can be a little confusing at first when you first look at a problem like this, 3 minus 2. I didn't mean to erase all that, but 3 minus 2. When you look at a problem like that, then you would say, that's an easy problem, except it starts to get a little confusing in algebra. Because does the minus sign mean to subtract? Or does it mean that this negative 2 is a negative number? It turns out that you get the same answer either way you think about it. But what we're going to do is we're going to do the second process where you think of the negative sign as a negative number, like a negative 2. And then we're going to use a number line to help us figure it out, okay? So if we have a number line here, and I've drawn one. 0, the origin is right there in the middle. We have positive numbers this way, negative numbers this way. What we're going to do is we're going to solve this problem algebraically on a number line. So here I've turned this 3 into an arrow that goes a distance of 3 spaces. So what we do is we take this. We have started at the origin. Oops, so you can see that I've started here. I've drawn a dotted line up and I'm going to go 3 spaces to the right. The reason I go to the right is because this is a positive 3. And then I'm going to make my dotted line up from here, and then I'm going to add the negative 2 to it. So I've made a negative 2 that goes only 2 spaces. And if I put that there, right above it, this time I'm not starting it at the origin. I'm starting it where my last arrow ended up. So I put it here, and now it's 2 to the left. And you can see that where it ends up, if I did it right, where it ends up is the answer to the problem. So 3 minus 2, we know that it's 1, but where it ended up on the number line is also 1. So that's how they want us to think about it for these next problems. So let's look at example 5.2. And if you're following along, this is on page 26. They want us to add positive 3 minus 5. Okay, so I'm always going to start at the origin. The origin is this 0. And first thing I'm going to add is positive 3. So I need to go 3 spaces. 1, 2, 3. I go 3 spaces to the right because it's a positive number. Then I'm going to go up from there, and I'm going to go negative 5 spaces. Negative 5 means to the left. So 1, 2, 3, 4, 5. Okay. I went negative 5 spaces, and I ended up at the negative 2. And the answer to 3 minus 5 is negative 2. Bam, that was kind of cool, huh? And if you want to see what that looks like algebraically, the problem would look something like this. Positive 3 plus negative 5 equals negative 2. That's basically what we just did. I know you're like, whatever. I could have done that in my head. But you got to do it this way because the problems are going to get more complicated and you need to understand this part. Okay, so example 5.3. They want us to use the directed numbers and the number line to add negative 5 and positive 3. So let's do it. Let's start at the origin. Here's the origin. I draw my dotted line up, and we're going to do the negative 5 first. So I'm going to go 1, 2, 3, 4, 5. It's easy to do it when you've got a grid pattern. So I didn't draw it very straight, but that is negative 5. Now I'm going to go up from there. If it was a negative 3, I would keep going in that direction, but it's not. It's a positive 3. So now I'm going to go 3 to the right. 1, 2, 3. Okay, so that's 3. And if I go down, boom, 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 that's my answer. Negative 2 is the answer. So if I were to draw that out algebraically, it would be negative 5 plus positive 3 equals negative 2. Now, what did we just notice? We just basically did the same problem, but we did plus 3 minus 5 the first time, and now we did minus 5 plus 3. We just switched the order. Get that corn out of my face. And of course we did, because the commutative property of addition, here's just a little reminder, means that the order doesn't matter. The order doesn't change the sum. It doesn't change the answer. So you can add 4 plus 3 and get 7, or you could change the order and do 3 plus 4 is 7. And that is true even if those numbers are negative numbers. So if it was like negative 4 plus 3, you could also add 3 plus negative 4. As long as you keep the negative with the right number, right? And then you're still going to get the same answer. So that's really cool because you can flip them around sometimes. Let's do another example. It's example 5.4. If you're following along, it's on page 27. It says use directed numbers and the number line to add positive 2 and positive 1. Okay, so here we go. We're going to start at the origin. Of course, we always start at 0. Make your dot, 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 going up. And we're going to do plus 2 first. So 1, 2, bam, plus 2. And now they want to add plus 1. So I'm just going to put it on the tail of that arrow, one spot, plus 1. There's my answer. I get 3. So we see from the graph that positive 2 plus positive 1 equals positive 3. 2 plus 1 is 3. I mean, these are the problems we're doing, but you're going to have to trust me that you have to go through this process so that you can do way more complicated stuff later. Example 5.5, let's jump in. It says use directed numbers and the number line to add negative 2 and negative 1. Okay, we're going to start at 0. We're going to go dot, 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 all the way up. And then I'm going to use a brighter color because I like bright colors for this. And we're going to start with negative 2. So I'm going to go 1, 2. Okay, negative 2. And then they want us to add negative 1. Now it's negative, so I'm going to go to the left again. So I'm just going to put it there, negative 1. And then I ended up at negative 3. So we can see from this example that negative 2 plus negative 1 equals negative 3. That's how you would write it. Bam! Okay, and guess what? You can change the order. So if you wanted to add negative 1 plus negative 2, you would get the same answer. It doesn't matter. And you could change those arrows around too, right? So you could put like a shorter arrow for negative 1 and then do 2 minus 2. You'd end up at the same place. So that makes sense. The commutative property of addition, it's true. Turns out it's true after all, and we are nearing the end. That's why you've got a picture of the end right there. Okay, example 5.6, we are going to add these numbers. Guess what? Of course they're going to make it hard. Of course, because they know how smart you are. You can handle this. They're not just giving you 2 numbers, they're giving you 4 numbers all at once, mixing signs. There's a negative, there's some positive. Ooh, this one's going to be fun. Okay, let's see how it turns out. Let's just add them in the order that they gave us. Of course, we're going to start at the origin again. We go up from 0, and let's start with -4. Let me get a color I can see. So 1, 2, 3, 4 to the left. So I'm going to go -4. Now I'm going to go up from there, and I'm going to add the next number, which is +2. So I'm going to go 2 to the right. 1, 2. Okay, that's +2 right there. And then they want us to add a -1. So I'm going to go up from there and just go -1 space. Boom. Easy peasy. And then we're going to go up from there, and we're going to add a +5. So 1, 2, 3, 4, 5. +5. And if I did everything correctly, I land right there at that +2. Pretty sweet. And what this shows is that this math problem is equal to 2. All right, but let's say you didn't like that order that they gave you. Let's say that you put them in, I don't know, some sort of numerical order like 1, 2, 3, 4, 5. Okay, so what if you did that? What if we changed the order? Let's erase this. Boom, we can erase it. All right, if you didn't like that order that they gave it to you, let's just prove it to me that the commutative property is true. We are going to start with -1. Okay, start at the origin. Boom, boom, boom. Let's go -1. Boom, -1. And then the next thing we're going to add is that +2. Okay, let's go up from there and go 2 spaces over. 1, 2. There's your +2. I did that. Now, what if we add the -4 next? Okay, I can do that. I go straight up from where I left off and go 1, 2, 3, 4. Boom, right there. There's my -4. Okay, did that one. Last one to do is this +5. So let me erase some of this so it doesn't get too messy. We're going to go up, and then we're going to add +5. 1, 2, 3, 4, 5. Boom. Guess what? We ended up at that +2. The answer was +2. It's always +2. It doesn't matter the order. That just shows that the commutative property is true. And guess what, Addie? We are all done with this lesson and time for you to do your homework, okay? Love you. Have a great day. Bye.